So first of all, basic things से बात करेंगे. First of all, that we know that there are different kinds of carbons, right? There are different kinds of carbons. We study about different kinds of carbons. So let's go through that. So first will be the types of carbons. Types of carbons. What kind of carbons can be there? There can be one primary, one secondary, there can be tertiary, and there can be neo. Neo is important. First of all, primary is like CH4 is a primary, CH3, CH3. They both are primary. Suppose if you are, so this is for the primary carbon. For secondary carbon, it will be suppose CH3, CH2, CH3. So out of this, these are primary, but this is secondary. Okay, so this carbon is secondary carbon. What about tertiary carbon? Tertiary is just like this. Tertiary is CH3, C, CH3, H, CH3. This carbon is a tertiary carbon. And suppose if we have CH3, C, CH3, CH3, and CH3, that carbon, this carbon is a neocarbon. This carbon is a neocarbon, right? So neo is nothing but a tetracarbon. So now let's move on to another types. Now there are different kinds of carbons. See this very quick. So we have discussed primary, secondary, tertiary, neo. Another type of carbon is vinylic carbon. Vinylic. What is vinylic? CH2 double bond CH. This carbon is known as vinylic carbon. The carbon which is attached to CH2 and it is double bonded, that is vinylic carbon. So for example, vinyl chloride. Like CH2 double bond CH, Cl. Another kind of carbon is allylic carbon. Allylic carbon. It is just one carbon step up. Like it will be CH2 double bond CH, CH2. This carbon is known as allylic carbon. Example, allylic chloride. Please write along with me. That will be really helpful for you guys. CH2 double bond CH, CH2. This is the allylic carbon. Then Cl. This is allylic chloride. This is vinylic chloride. Okay. Now, and the type of carbon is, it can be also benzylic. It can be also benzylic. Like carbon which is attached to a benzene ring, this carbon is known as a benzylic carbon. This carbon is known as what? Benzylic carbon. For example, benzylic chloride. For example, benzylic chloride. This is nothing but this CH2Cl. Okay, right. Now carbons can be also alpha, beta, gamma carbons can be also there. We know that alpha, beta, gamma nomenclature. So any carbon which is just beside the functional group is known as the alpha carbon. उसके बाद वाला जो कार्बन होगा वो क्या होगा? बीटा. उसके बाद वाला गामा. Like for example, suppose we have CH3, CH2, CH2, COOH. For here, this one is the functional group. This is the functional group. So उसके बाजू वाला जो है this one sorry, this one will be, so this one will be the alpha carbon. This carbon will be the alpha carbon. This carbon will be the beta carbon. This carbon will be the gamma carbon. So we have studied in biochemistry as well these kind of things. So for example, if we take this case, so for example, we have, if we have CH3CH2OH, so this one is the functional group, this will be alpha carbon and this will be the beta carbon, right? Now there is another type of carbon is known as the chiral carbon. It is also known as asymmetrical carbon. What? Asymmetrical carbon. We know that in a asymmetrical or chiral carbon, we have all the four groups different. For example, suppose if we have C, there is bromine, there is chlorine, there is iodine, there is fluorine. So this is a chiral carbon. But if we have CH2Cl2, so it will be CHHCl. So these two are same, these two are also same. So it is not a chiral carbon. It is not a chiral carbon. So there is chirality, and we will discuss in the isomerism that it is a non-superimposable mirror image. Okay, so if we want to discuss about the optical isomerism, we know that we should have a chiral carbon and there should be a non-superimposable mirror image. So we will discuss that in the isomerism section. Let's not discuss about the chiral carbon. So we just will write one thing, that asymmetrical carbon compounds shows optical isomerism. Right. So these are the basic things we need to remember. Now, alcohols. If we discuss about the alcohols and alkyl halides, so they can be also primary, they can be also secondary, they can also be tertiary, based upon the type of the carbon which are attached to. If a OH is linked with the primary carbon, then it is a primary alcohol. If the OH of the alcohol is linked to the secondary carbon, then it is a secondary alcohol. If it is linked to a tertiary carbon, then it is a tertiary alcohol. For example, so suppose this is CH3CH2CH2OH. So this was a primary carbon. So this is a primary alcohol. Suppose we have this. This was a secondary carbon. So this is a secondary alcohol. Suppose we have this tertiary butyl alcohol. So this is a tertiary carbon. So this is a tertiary alcohol. Neo form of carbon cannot form any kind of alcohols, right? Because all of the four are bound with the CH3. Now see this carefully. Suppose now if you're talking about alkyl halides, suppose in case of alkyl halides, suppose we have CH3, CH, CH3, CH2, CH3. This one is the primary, this one is the secondary, this one is the tertiary, this one is the primary, right? So if we give Cl, so if anyone gives you this kind of question and in the reaction there is Cl, what type of alkyl halides can be formed? So it can form primary alkyl halides. Primary alkyl halides can be formed where it will be CH3, CH, CH3, CH2, CH2, Cl. If the Cl binds over here, then it will form a secondary alkyl halide. If the Cl binds over here, then it will form tertiary alkyl halide. So if in the question, if they give you a question like upon hydroxylation or upon halogenation, what type of alkyl halides can be formed? So see what type of carbons are present over there. If there is primary, secondary, tertiary, so all of the three kinds of alkyl halides or all the three kinds of alcohol can be possible. Which one will be the major product and the minor product? That will be a different section. Okay, because in JAM there is a particular section called MSQ, multiple answer correct. So there can be all the three will be correct option. So just keep this in mind. Now amines can also be primary, secondary as well as tertiary, right? Like for primary it will look like this, CH3 CH2 NH2. Secondary it will look like this, it will look like CH3 NHCH3, and tertiary amines will look like this, CH3 N CH3 CH3, because the nitrogen has only 3 valencies. So if I give you now a question, please give the answer to me. Find out total number of alcohol by CH3 CH CH3 CH2 CH CH2 CH2 CH3. Option A 1, option B 2, option C 3, option D 4. How many types of alcohol can be formed from this? And if you want to know what will be the IPC name, so it will be 1 2 3 4 5 2-methyl pentane. So what will be the answer? Please let me know in the chat section. What will be the answer? How many types of alcohol can be formed? Let me know in the chat box. Okay, so Preeti is saying 4 types of alcohol. But we have studied there are only 3 types of alcohol: primary, secondary, and tertiary. Mainly, they are talking about the types. Because the same type will be just exactly the same. So, how many types? Right, 3. 3 will be the correct answer. Why? Because we have primary carbon, we have secondary carbon, these two are secondary carbon, this is the tertiary carbon. That's why, and these are all primary carbons. So, yes, so that's why the answer will be 3. Very good. Now you tell me, suppose if I give you a question like this, this is the case, it will give how many types of alcohol? 1 2 3 4. Tell me this question. How many types of alcohol can be there? Just take any guess and tell me. Okay. How many types? I asked you how many types. Alcohol can be only of 3 types. You can't answer 4. Very simple. Primary, secondary, or tertiary. There will be one answer. Answer will be A. Not 2, not 2. No, 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 no. Just think in a very simple manner. You have only primary carbon. Bus. So it will form only because we'll see that this benzene ring won't react. Okay, this benzene ring is resonatically stable. It won't react to form an alcohol. So it will form only CH2OH, and that is nothing but a primary alcohol. So we'll discuss in the reaction mechanism that these kind of electrophilic substitution reactions, okay, so the benzene ring won't react because the benzene ring only shows electrophilic substitution reaction, and this alcohol formation is a nucleophilic substitution reaction. So yeah, that is the point. So we'll discuss in the reaction mechanism section why this benzene ring won't react to form the, like, it won't form like this. It won't normally, it won't form like this. It won't form. It will take place under different conditions, right? So only one type of alcohol will be there. So now let's move on to the next section. So first of all, we will discuss with all the functional groups. So now our topic will be the functional groups. Functional groups. First of all, we'll discuss about carboxylic acid. We'll discuss about carboxylic acids. So the structure is COOH, or it is known as carboxylic acid, or it is also known as, because in case of IUPAC you will see that alkanoic acid. Suppose there is propane, so it will be propanoic acid. Okay, suppose it is a butane, so it will be butanoic acid, so it will be alkanoic acid. Right. Now, so first of all, you need to have some key points. Please write it down with me. First point, acid turns. These are the basic things they ask question. Blue, litmus, red. Second, acid gives carbon dioxide. We know these kind of things when it is reacting with bicarbonate. Okay, so this is an important property. So if there is a particular RCOOH plus HCO3 minus, there will be RH and CO2. Suppose there is, sorry, I'm really sorry, this won't be the reaction, just cut it out, sorry. Suppose we have a bicarbonate, like suppose this is the RCOOH, and suppose there is sodium bicarbonate, sodium bicarbonate. So it will form actually RCOONA plus H2CO3, and we know that H2CO3 will dissociate into H2 plus CO2, and this CO2 will be released. This CO2 will be released. Okay. Now, third point, acids react with alcohol to give ester, or ester. Okay, so normally it is present in presence of some different acid, in presence of mineral acid. So suppose mineral acid, suppose this is a weak acid, like we write it as H plus. Okay, because we know that in we have studied that जो प्रोटॉन डोनेट करता है, that is an acid. So yeah. So suppose there is RCOOH plus HOR dash. So this is a acid and this is an alcohol in presence of a mineral acid. So we'll write H plus. It will be formed like this. So you will see that OH will be released. OH will be coming from the acid and H will be coming from the alcohol. It's a reverse property. Normally acid donates H plus, but in case of the ester formation, from acid OH will be released and H from the alcohol. As a result of that, it will form RCOO R dash plus H2O. Okay, so these things are really important. Suppose if they give you like a question like, suppose we have this CH3CO OH plus HO, this is 17. So it's a radioactive oxygen, suppose. So we'll write it as O star H. This is an alcohol. So you will see that under mineral acid, CH3CO, okay, CH3CO, O star R. So from this, it was concluded that this OH was released. This OH was released from the acid, and this H was released from the alcohol. That's why this O star is coming in the ester. If only H plus was released from the acid, then you will not have this O star or the radioactive oxygen. So these are the simple things. So yeah. Now so note, if any acid gives OH and alcohol gives H plus in the reaction, then ester is formed, right? So suppose if you have, let's see, suppose we have a glycerol. Okay, suppose we have a glycerol. Glycerol is an alcohol. So CH2OH, CH2OH, and if we react it with 3HNO3, nitric acid. Okay, so this is an acid, this is an alcohol. The result will be an ester. Okay, so let's see how it's happening. So we have 3 nitric acid. So we'll write in this way. Acid will release OH. So we know that this is HNO3, but we will write OH over here. So one H and one O gaya. So NO2. OH, NO2. OH, NO2. This was the 3HNO3 plus plus plus. So we'll write in this way. H पहले लिखेंगे ऐसे, HO, HO and HO, because from the acid OH will be released. Now ये जाएगा, this will go out, this will go out, and this will go out. So if it goes out, then what is formed? CH2O, okay, NO2, CHO, NO2, CH2O, NO2. This is actually an ester, but this is nothing but ट्राई So जो हम आंख में लगाते हैं ग्लिसरीन, so this is this. So it is nothing but an ester. So it is nothing but an ester or ester. Right. So these are the basic things. Now, other points. Some important information. Some informations you need to remember about carboxylic acids. What? First point, formic acid, that is the HCOOH. In vapor phase, this formic acid is known as formalin. Formic acid in vapor phase is known as formalin. Second, suppose we have CH3COOH, acetic acid. So on solidification, this acetic acid is known as, now it is known as glacial acid. Third, in vinegar, acetic acid is about 7%. 7% acetic acid is present in vinegar. Okay. Carboxylic acid, suppose if you have two carboxylic acids, suppose this is one and this is one. So it can actually, these are all the monomers. These are all monomers. If we react to carboxylic acids, it can form a dimer. It can form a dimer. So it will be like, suppose this is one carboxylic acid. Okay. And this is another carboxylic acid. And they can have an hydrogen bonding between them. So dimer mein, in case of a dimeric carboxylic acid, so there is a hydrogen bonding. These are the important points you have to remember. Now, fifth point. Suppose we have a peroxy acid. Peroxy acid is RCOOOH. 3 O are there. Peroxy, because there is a peroxy bond. Suppose, see this very carefully. Peroxy acid, normally it is present. Suppose if you draw the structure, so it will be this. There is he like this. So this bond is known as a peroxo bond. This bond is known as a peroxo bond. And it is seen that the peroxy acid shows an hydrogen bonding with itself. So suppose if we have the peroxy acid and normally you have one carboxylic acid. Suppose this is, suppose there is another carboxylic acid, COOH, so we'll write it like this. But there is no hydrogen bonding between the O and the H. So that's why the release of H plus, is favored. And that's why it is a good acid. Not good, strong acid. But as there is a hydrogen bonding, in the peroxy acid, the release of H plus is not so easy. As the release of H plus is not easy, that's why, so release of H plus is not easy. That's why it is a weak acid, weaker than carboxylic acid, weaker than carboxylic acid. It's not peroxy, it will be peroxy. So the acidic character, so acidity अगर हम plot measure करें, so carboxylic acid is highly acidic than peroxy acid due to the hydrogen bonding. Important. This is important. Okay. And also one important thing is that suppose if you release this H plus, then what will happen? There will be O minus. This O minus will come over here. This will go over here. As a result of that, this structure will be formed. C O minus partial double bond character, and this is what we call is a resonance. So after you release the H plus, the intermediate structure, this RCOO minus, is resonatically stable. This RCOO minus is resonatically stable. But if you see over here that in the peroxy acid COO, if you release this O minus, you don't have a conjugate double bond. So there is no resonance. That's why also carboxylic acid is more stronger acid than a peroxy acid. Right. Next, I think it was 5, then 6. Carboxylic acid reacts with carbene to form ester or ester. Suppose so this is the reaction, like this is CaCH. Suppose we have this carbene, okay, in presence of heat, it will give you CH3COO CH3 plus N2. What will be the mechanism? Very easy. Suppose we have this CH3COOH, right? Now from this, the carbene will be released. CH2 dot dot. This is the carbene. This is the carbene. We'll go in details about the carbene, carbocation, carbon anion in the reaction mechanism. But I think you know this as you had a chemistry in your +2. So this is a carbene. All right. Now what happens? See this very carefully. So this H plus is released. RCOO minus. Okay. This H plus now binds with this carbene and it forms CH3 plus. This is RCOO minus. This is CH3 plus. Positive attracts the negative. This will come and bind over here. This will come and bind over here to form RCOO CH3. Here the R is CH3, so it will be also CH3. Right? जो निकल के आ गया, that is the N2 that is present over here. So the main important point is that if you, so what is the gist? Suppose this is the RCOOH. If you have CH2N2, then what will happen? It will be released in the form of carbene. This H plus will bind with the carbene. It formed RCOO minus. It will form CH3 plus. It will bind with each other to form RCOOH3 CH3 plus. This will be present in 2, 1 and 2. Okay. Right. This is important. So ester will be formed. So these things are really important. Now 7. Suppose if you have beta keto acid, in the beta carbon there is a keto group, okay, beta keto acid or beta unsaturated acid. Why? Because in the keto group there is a C double bond O. Double bond means there is an unsaturation. So beta unsaturated acid. On heating, it will give CO2. So this is a kind of decarboxylation. Okay. So suppose, for example, we have this CH3, C double bond O, CH2, C double OH. So this is one will be the alpha carbon and this is the beta carbon. In the beta carbon there is a keto group or this is an unsaturation. This is an unsaturation. So if you want to heat it, अगर हमने heat किया, so what will happen? There will be a decarboxylation. So this will be moved out. This will be moved out. So minus CO2 will be there and it will be CH3CO CH3. So in this way also we can convert a beta keto acid to a ketone. So this is plus CO2. So this is a decarboxylation. So the carbon number is decreased by 1. It is a step down process. It is a step down process. Okay. Next, 8. Suppose now I think you have studied about one thing. I think you have forgotten. There is a word called soda lime. Can you tell me what is soda lime? Please let me know in the chat section. Can you remember what is soda lime? It is a mixture of two things. Chat box में लिखो. What was soda lime? Do you guys remember or not? It's okay to not remember. Yes or no? Tell me. So soda lime was NaOH. Okay, Seoshi, it won't be COH whole twice. It will be CaO, calcium oxide. Okay, so NaOH plus CaO. This was soda lime. Okay. Yes, Neashish, you're correct. So this was an important thing. If you react the carboxylic acid with soda lime, then what will happen? You will form an alkane. You will get an alkane. So carboxylic acid under the treatment of soda lime, you will get an alkane. Suppose example, we have CH3. So there is nothing but this is also a decarboxylation reaction. See this COO is released plus CO2. This is also a step down process. Suppose we have CH3COOH, NaOH plus CaO. This will be released. So CH3 plus H, so that will be CH4 plus CO2. This is methane. Suppose if you have CH3COOD, in case of hydrogen, there is deuterium. Same thing will happen. No need to worry about it. it will be like this. So CO2 will be released. So don't write here methane. It will be CH3D plus CO2 because ये release हो जाएगा. So D plus H, there will be CH3D. Oh, I'm really sorry. No. Sorry. This will be also CH4. This will be also CH4. Now what happens? This actually goes out and this H actually comes. This H actually comes. So note NaOH का जो H है, it actually comes and binds with the R group. So that's an important point. Don't make my mistake. So CH3COOD, if it is present, soda lime treat किया, this hydrogen will come and bind with the R group, CaO. So CO2 will be released and CH3 and this H, that is CH4. Suppose if you did this, D is present over here as well. Sorry, suppose there is H, okay, and there is NaOD, deuterium, and CO, that is also a soda lime, just the hydrogen is a deuterium. Then what will happen? This CO2 will be released plus CH3D plus CH3D. So this one is important. The hydrogen of NaOH will bind to the R group. Important. Suppose there is a question like CH3, CH2, COOD, NaOH plus CaO. What will be the answer? CH3, CH3, ethane. And in case if there is a question like CH3, CH2, CH2, COOD, NaOD plus CaO, then the answer will be CH3, CH2, CH2D. Because in the NaOH, the hydrogen is replaced by deuterium. Right? These are the things you need to remember. Okay, right. Very good. So suppose if you have HCOOH, NaOH plus CO. Then what will be the answer? This will go out, this H will come and bind to this. So here the R is nothing but H. So H2 plus CO2. Suppose same case HCOOH, NaOD plus CO, HD plus CO2. Right? That is the case. So is it clear, everyone? Please let me know in the chat section. Is it clear or not? So this was all about the carboxylic acids. We'll go in details when we do some name reactions, but basic things complete. So is it clear? Then I can give you some questions to solve. Let me know it's clear or not. Okay, I got one answer. Others, please let me know. Okay. So do these questions. Let me give you some questions. So I'll just randomly solving some questions, okay? Because you can't give me the answers because I won't give you the options. So just I'm going through and just you let me know that it's okay or not. Right. Right. Now, suppose if we have this CH3, CO, CH, COOH, and COOH. Okay. Now, suppose if we heat this, what will be the answer? So, I'm doing some of the questions. See this. This is the carboxylic acid. This is the alpha carbon, and this is the beta carbon. Right. Now, as it is the beta carbon, so what will happen? You know that there will be decarboxylation. So both of the cases, decarboxylation will be taking place, and the answer will be CH3, COCH3. Because in this carboxylic acid also, this is the alpha carbon and this is the beta carbon. So we know, we have studied that in case of the beta keto acid or beta unsaturated acid, if you heat that, so there will be a decarboxylation. Now you tell me this thing. This is the question for you. Beta keto or beta unsaturated? Okay, that is important. What will be the answer? Option. One second. Right. One second, guys. These are the four options. Tell me which one will be the correct answer. Beta keto or beta unsaturated? That is the key. What according to you will be the correct answer? This is that kind of a question. If you can solve this, then all the questions from this section will be okay. In case of beta keto or beta unsaturated, if you heat it, then there will be decarboxylation. If in the beta carbon there is an unsaturation, then there will be what? There will be decarboxylation. So then what will be the correct answer? Socho. Okay, so we got some answers. A, Shancharika is saying C. Okay, others, what do you think? Srijita is also saying A answer, right? So Preeti also A, Shudeep A, Sancharika C, Srijita A. Okay. Then others, Nilanjana is saying D. Okay. Okay. So the answer is not A. Answer will be C. Why? Because see this very carefully. This is the carboxylic acid. This is the carboxylic acids. For this functional group, this is the alpha carbon. This is the beta carbon. Whereas for for this case, for this functional group, this is the alpha carbon and this is the beta carbon for this case. Now, for this case, see this very carefully. See this very carefully. Do you see in this case? Do you see any kind of unsaturation in this carbon? If it is the beta carbon for this case, you can't see. There is no unsaturation in the beta carbon for this functional group. But if you consider this functional group, now, see this very carefully. C and B, they are, oh god, sorry, I just gave the same. Okay, C and B are the same, right? So it will be like this. Okay, like this. Now, the point here is, if you consider this functional group, this is the alpha carbon and this is the beta carbon, and there is an unsaturation in the beta carbon. There is an unsaturation in the beta carbon. Now, only in this carbon, this is the beta unsaturated acid we are going to consider. This, if you consider this acidic group, there is no beta unsaturation in this carbon. So only this CO2 will be released. So what will happen? So this is the case. This is CH2, COOH, and this is COOH. So this CO2 will be released, and this will be formed like this is the case. CH and this H will bind over here, CH2, the rest will remain the same. Suppose if this carbon was the, so what was the option B? If this carbon is the functional group, then there will be a removal of carbon dioxide from here, but it is not forming the beta unsaturated carboxylic acid. That's why it's not releasing. But this for this functional group, it actually forming this beta unsaturated carboxylic acid. That's why here from this carbon dioxide it is being released. So these things are really very important. You need to follow. Now, so these are the important things you need to remember. Now let's move on to the next section. That is the ester or esters. So let's study about esters. So we write in case of the IPAC name, we write as alkyl alkanoate. Okay. So this is, suppose this is R C O O R dash. So this one is the alkyl, this is the alkanoate. Suppose we have CH3 CH2 C double O OCH3. Then this is the alkyl group, that is the methyl. This is the ethanoate. So it will be methyl ethanoate, जिसके साथ acidic group is attached, that is the O8 form, right? Suppose this is CH3CH CH3 COO CH2 CH3. So this is the isopropyl group. This is the isopropyl group and this is the ethyl group. So what will be the name? The name will be ethyl isopropanoate. Ethyl isopropanoate. The name will be ethyl isopropanoate. These are the basic things. So suppose if you have this, what will be the name of this? Suppose if we write, this is also an ester. This is also an ester. See this, there is a C double bond O. COOO group is present. This is nothing but, see this, how many carbons are there? So 1, 2, 3, 4 and 5. So it will be cyclo, as it is a cyclical structure, pentanoate. Cyclopentanoate. These are important. Now, what are the informations you need to remember? So these are the informations. First point, ester is normally neutral. It is not acidic or basic, it is neutral. Ester is neutral in nature, having fruity smell. Very important point. Very important point. Sorry. Really important point. Fruity smell. Important. We have studied that esters are formed from the acid and the alcohol, in which the OH group is coming from the acid as well as the hydrogen is coming from the alcohol. We have studied all of this, right? So suppose if they give you a question like this, okay, sorry, not like this, like this, then under mineral acid it will be, okay, C, OH will be released from the acid, so CO, okay, and H will be released from the alcohol, so this will be the structure. That is also an ester. 1, 1, 2, 3, 4. This is a cyclobutanoate. That is also an ester. So basic things are present over here, right? So now let's move on to the other things. Third, these are the amines. These are the amines. So RNH2. So it is known as alkane amine. Suppose if there is CH3 CH2 NH2, then it is known as ethanamine. Ethanamine. Suppose, now see this very carefully. Suppose there is CH3 CH2 over here, NH, and there is a Cl. then it is known as N-chloroethanamine. It is not ethanamine, it is ethanamine. 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 Suppose if we have CH3, CH2, CH2, NH, CH3, what will be the name? N-methyl propanamine. Right? Very good. Suppose if we have, these things are important. Why I am writing this? Because they can give these kind of names and give the question. So suppose they are giving this. So it will be, there are two NN. Okay. Sorry. Suppose there is CH3. NN dimethyl methenamine. Suppose there is CH3N C2H5 CH3. You just tell me what will be the name. You just tell me what will be the name. What will be the IUPAC name? This is an important question. What will be the IUPAC name? Write it down in the chat box. Tell me. Okay, so Preeti is saying, okay, yeah, you made the same mistake. Okay, don't make this mistake. Okay, so here now the longer chain will be in this direction. So this will not be a side chain. So that is the main rule of IUPAC, right? Longer chain, the shorter will be in the side chain. So it will be like you're coming from here. So there are two methyls and it is an ethane. So it will be NN dimethyl ethanamine. I also made these mistakes. So it's okay, no problem. Ethanamine. Okay, so don't just see that from in this direction. See from which direction there will be a longer chain. So there are two carbons. So 1, 2, then third main NRI. और यहाँ पर second में NRI. So always take the longer one. So now you just tell me. I think now you can do this. CH3, CH2, 95, CH2, N, CH3, sorry, CH2, CH2, 115, CH3, CH2, CH2, 208, CH3. So suppose this is R, this is R1 and this is R2. So we will consider only in the longer direction. So this one is the longer direction. So you have to consider like this. So you will see, right, in R1, R2, Rme. Is it clear, everyone? Please let me know in the chat section. Is it clear or not? Clear? Very good. So, okay, very good. So suppose if you have this, what will be the name? What will be the name of this? So the name is, this will be, in the cyclo there are how many carbon? 1, 2, 3, 4 and 5. So it will be N cyclo pentamine. Pentanamine. Why? Because the nitrogen is in cyclopentane. Nitrogen is in the cyclopentane. So these things are really important. You have to remember this. Okay, right. Now see this. Primary, secondary and tertiary amines are functional isomers. We'll discuss in about these isomers in the isomerism class. So primary, secondary and tertiary amines are the functional isomers, and they show different properties. So we will discuss what are the different properties in the isomerism section. Okay, but primary, secondary and the tertiary alcohol or alkyl halides, okay, they are not functional isomers of each other. This is a very important statement. Okay, they are not functional isomers of each other. Right. So there are some key points. There are some key points you need to remember. What are the key points? First, primary amine. I will give you some important data from the primary amine. Okay, so primary amine, just remember this thing. These are the direct questions. It actually gives mustard oil test. Mustard oil test is done by primary amines. Second, primary amines they also give carbylamine test. So we'll discuss carbylamine after a few minutes. Okay, when we are doing the isocyanate functional group, carbylamine test. This is very important. Jam in this question has come in many times. Where? So in which chloroform reacts with the primary amine, in presence of KOH, it gives isocyanide. From the isocyanide, we get a bad smell. So the reaction is, suppose this is the primary amine, this is the primary amine, this is the CHCl3, this is nothing but the chloroform. Okay, in presence of KOH, actually it's aqueous KOH, we get CH3NC. Normally CN is known as the cyanide, NC is known as isocyanide, and here we get a bad smell. This is the isocyanide. So this is the carbylamine test. You need to remember this thing. This is really important. Okay, so this is the test you need to remember. Okay. Very, very important. Carbylamine test. Right. Another important thing, third, if you react NH2, this is a primary amine. If you react it with HNO2, okay, or they can also give NaNO2 plus dilute HCl or HCl. So this NaNO2 plus HCl actually gives this HNO2. Okay, so they can give either of this. Okay, either this or this. So you will get this. Sorry, you will get ROH. This is also an important reaction you have to remember. This is also an important reaction. This is also important. So tell me, what will be the answer of this? Suppose in the R group, if you have a acyl group, okay, CH3, CONH2. This group is known as acyl. Sorry, it is not acyl, it is acetyl group. Like we have studied that in glucosamine, suppose there is a glucose, in this OH there is NCO, CH3. Okay, and there is a, so it is nothing but N-acetyl glucose. And if it is a glucosamine, then it is N-acetyl glucosamine. So let's not go there, but COCH3 is the acetyl group. Now if you do this reaction, what will be the answer? So इसके जगह क्या आ जाएगा? OH आ जाएगा. So this will be CO and then OH will come, carboxylic acids. Important. From acetylamine you can also get CH3COOH. Now another important thing, suppose if this NH2 is now present on the benzene, if this NH2 is present over the benzene, we'll again discuss these kind of reactions in the later parts of the organic chemistry, but as we are studying amines, I am discussing everything. If you do this, you will not get any OH over here. Okay, suppose if you are doing NaNO2 plus HCl, you will not get OH. This is another important reaction you need to remember. You will get this diazonium salt. This is known as diazonium chloride. This is also an important thing you need to remember. This is also important. So if you have done this, then this is a beautiful question. It was asked in I think in TIF, I think. So what will be, if you do this, then what will be the answer? The answer will be, for this benzylated amine, this will be N2Cl. This is an aliphatic amine. It will be CH2OH. Important. Okay. So remember this. So we need to remember, not in case of the benzene, you have to remember one important thing. And what is that? So let me write in a different ink. Note. Double bonded carbon. Double bonded carbon with NH2 group gives diazonium chloride. Gives diazonium chloride. That is N2Cl. And single bonded carbon will give alcohol. So you see that this carbon, there was a double bond. There is a double bond. So if we give this kind of a question like over here, so what will be the answer of this question? CH2 CH NH2 double bond. CH CH2 sorry C NH2 NN2 plus HCl. So this will be CH2C N2Cl because there is a double bonded carbon. Then double bond CH CH2 OH because this is a single bonded carbon. This is a double bonded carbon. Okay, very good. So let me give you one question. Okay, let me give you one question. Okay, another important thing. If you have RCN, if you reduce it, you will get RNH2. You will get what? RNH2. No, one second. Not RNH2. You will get RCH2NH2. There will be H2 and there will be another H2. CH2NH2. This is also important. Important. Right. Okay, these are the things we need to remember. So let me give you some questions. Let me give you some questions. Or I will just explain you this kind of questions. I'll show you some examples. Like suppose we have NH2, CH2, CONH2. If we do this, HNO2. Okay. What will be the answer? It will be on OH, CH2, C double bond OH, COOH. Now the point is here you can say that this carbon is linked with a double bond, but there is an O. I have showed you here. I think over here that CONH2 upon HNO2 CH. So though there is a double bond in the carbon, but as there is a oxygen which is an electronegative atom, it won't occur. But if you have given the condition like this, see this very carefully. This is one type of question. Let me give you another kind of question. It's a good question. Suppose this is NH2, there is CH2, there is CH, there is CONH2. Okay, CH double bond CH NH2 upon NaNO2 HCl. This is double bonded, so this will be N2Cl. This is single bonded, this will be N2Cl. This is CO, this will be OH, right? So now do this. So this will be OH, CH2, CH, C double bond OH, CH, double bond CH, and OH. Now if you heat it, what will happen? See, this is the functional group, and we know that in the functional group acids सबसे पहले होता है. It is the first priority, then alcohol बाद में होता है. So this is the alpha carbon and this is the beta carbon, and in the beta carbon there is an unsaturation, so there will be an decarboxylation. So the answer will be CH2, CH2, CH double bond CH, OH. Is it clear, everyone? Please let me know. I am showing you some examples. These are important. Please write it down in your copies. Now, another example. Suppose we have this benzene ring, CONH2 and NH2, and we are giving NaNO2 plus HCl. So the answer will be what? Very easy. This is CO, though it's double bonded, but it's linked with O, so it will be OH. But it is this carbon linked with the double bonded carbon. This will be N2Cl. Another example. Let me make one. Suppose we have this benzene ring. We also have a cyclohexane. Suppose we have this CONH2 over here, NH2 over here, and NH2 over here. Okay, we do a NaNO2 plus HCl. We get product A. We give a heat treatment to get a product, suppose C, and we are giving suppose soda lime to give a product B. Now just see what I am doing. Okay, please write it in your copy, because as it is an online session, you cannot write the structures and tell me, or it will be too much time consuming if I make you some 3 or 4 options. See this very carefully. I will give you some options for the questions. Don't worry. So say this will become OH. This is single bonded, this will also become OH, and this is double bonded, it will become N2Cl. So A will be what? So let's do it in this way. NaNO2 plus HCl. You just follow me. I'm doing correct or not. If I'm making mistake, let me know in the chat box, or unmute yourself and tell me. Okay. So this will be N2Cl. This will be C double bond COH. This will be OH. Right? Very good. Now this is the A. Now we are doing a soda lime treatment. So we know if we do a soda lime, then there will be a decarboxylation. So on soda line treatment, which is nothing but NaOH plus CaO, it will be, this will be just H, so we are not writing here. This will be N2Cl and this is OH. This is the product B. Now we are heating it. Now we have to find that do we have any kind of do we have any kind of beta hydroxy beta unsaturated carbon? So yeah, there is alpha, this is beta, and obviously it is present, it can be present in this way also. So beta unsaturated carbon is also present over here. Beta unsaturated carbon is also present over here, right? So there will be also decarboxylation and you will get the same product. Okay, now I am giving you some questions which is having, tell me in the comment section, formation of alcohol by HNO2. Option A, CH3 CH2 COOH. Option B, CH3 NH2. Option C, CH3 CONH2. Option D, CH3 NHCH3. What will be the correct answer? Tell me in the chat box. Tell me which one will be the correct option. Sorry, correct answer, not correct option. Yes, you're right. Yes, B is correct because it's a primary alcohol. Primary, I mean, okay, this is not ये form करेगा, this is a secondary, I mean, so answer will be B. Very good. Now let's move on to here. Now let's talk about amides. Amides is very important. Amides, we can write amide as RCONH2. So we write as alkanamide. Alkanamide. Suppose if we have suppose CH3 CONH2, then it will give, it is known as 2 carbon ethanamide. 1 carbon 2 carbon. Suppose if we have CH3 CH2 CH2 CONH2, 1 carbon 2 carbon 3 carbon 4 carbon butanamide. Suppose if we have this kind of thing, CH3CO N NH CH3, then it will be N methyl group N methyl 1 2 ethanamide. Now do you remember this thing? What is this? This is 1 carbon. Okay, so methane diamide. This is nothing but your urea. This is urea. Now, what are the important things we need to remember? What are the important things? First of all, there is a particular reaction known as Hofmann degradation reaction. Hofmann degradation reactions. I think you have studied about this kind of reactions in your +2 level. This was a very important reaction. What are they? Suppose we have this CH3CONH2. This is nothing but an amide. Degradation reaction means this will be a step down reaction. So there will be one carbon less product, or step down reaction. You need to remember the reagents. The reagent is KOH plus bromine, Br2. Very, very important. Very important. Br2KOH. Reagent for Hofmann degradation reaction. Very important. Okay, KOH plus Br2. You will get what? You just remove this CO, CH3NH2. Primary amine. How many carbon was there? 1, 2. There is only one. Degradation reaction. Okay, remember this thing. 1. Another important you have to remember is CH3CONH2. If you react with P2O5, please remember this one. You will get what? CH3CN. You will get what? CH3CN. Right? You will get CH3CN. You don't have to remember anything regarding amines. It is done. Right? Done. Next, let's go to alcohol. So we know ethanol, propane-2-ol, ethanol, we know all these kind of things. First of all, some important structures, please remember these structures. Very easy structures. We know glycerol was glycerol. We have studied this. This was called glycerol. Then what is the structure of this? This is known as glycol or ethan glycol. 1, 2. Ethan glycol. You need to have consecutive 2 OH to form a glycol. Suppose if we have this CH2OH, CHOH, CH3. This will be propane, because 1, 2, 3. Propane glycol. Propan glycol actually, not propane, propan glycol. But CH2OH, CH2, CH2OH. This is not a glycol. So for a glycol, OH to consecutive carbons is important. It is needed. Right. So now I am giving you some important reactions. Okay. Please remember those kind of things. Just see those copies, see these notes before your exam. That will be enough. Okay. Don't worry about it. So we will discuss about entire chemistry. Actually, you have to take care of the physical one. Physical chemistry में क्या होगा? सिर्फ formula से question पूछेंगे. We'll discuss the physical chemistry by question answer sessions. Okay, but we'll go through the organic chemistry, because this organic chemistry is one of the portions many students actually don't answer well. So if we get an edge over here, so this will be easy. So organic chemistry is not tough, guys. So it is just needs a good practice. So don't worry. We'll have different consecutive sessions and we will actually practice those organic chemistry. So in the class, you will be in a better position. So just believe me and you will be in a good position. Suppose if we have a glycol, suppose CH2OH, CH2OH, this is a glycol. So if we react it with HiO4, okay, so there will be a cleavage. So heading the oxidative cleavage with HiO4, with HiO4. HiO4 is also known as periodic acid. So if you cleave this, cleave kar do, what will you get? HCOH. So you will get what? What are the important things you will get? That you will get once HCH, another HCH. H2 will be released. Suppose if we have this propan glycol, this was ethan glycol. If you have propan glycol like this, see, this is a propan glycol. So जो 2 कार्बन्स में हाइड्रोक्सिल ग्रुप प्रेजेंट है उसके बीच में क्या होगा? क्लीवेज होगा. So if we do this HiO4 treatment, periodic acid treatment, there is a cleavage between this and you will get this. What? HCHO plus CH3 इसका वाला CHO. Done. These things are really important. Let's move on to the next section. Now, we have studied in our plus 2 level that for oxidation, if we, because this is actually oxidizing, HiO4 is actually oxidizing this alcohol to aldehyde, right? Now see this very carefully. We know that if we actually oxidize alcohol, we will get a mild oxidation will give you aldehyde. And if you aldehyde, and if you actually, this is a primary alcohol. Primary alcohol. It will give you aldehyde. If you again oxidize, it will give you an acid. For a secondary alcohol, if you oxidize, you will get a ketone. You also get an acid. So in this case, these were all the primary alcohols. These were all the primary alcohols, right? You're oxidizing with HiO4. Cleavage is done, and this is oxidizing to 1 carbon aldehyde, HCHO. It is oxidizing to 2 carbon aldehyde, CHO. So now, suppose if we have glycerol, then it is CH2OH, CHOH, and CH2OH. Now, another important thing is that this oxidized secondary alcohol to ketone, it is unstable and it is rapidly formed to acid. But aldehyde is stable. But ketone from secondary alcohol is very much unstable. It rapidly forms acid. So normally we can say that if you actually oxidize the secondary alcohol, so after few seconds you will get an acid. But the aldehyde is more stable, but the ketone is not so stable. So now if we actually take a glycerol and we treat it with HiO4, there will be an oxidative cleavage. So now you just cleave this because there are consecutive alcohols in 3 of the carbons. So first of all, you cleave them. So this is a primary alcohol. You will get a 1 carbon wala aldehyde. So you will get you will get HCHO. Now this is a secondary alcohol. Secondary alcohol oxidation से क्या होगा? Ketone, but वो unstable है. It is unstable, so it will be rapidly converted to 1 carbon wala acid, and that is nothing but the formic acid. This is also a primary alcohol. There is a cleavage. It is converted to 1 carbon wala aldehyde. Please let me know, is it clear or not? Is it clear, guys? So HCHO plus HCOH plus HCHO. Very good. Very good. Suppose we have this thing. Suppose we have CH2OH and CHO. If we treat it HiO4, there will be a cleavage, oxidative cleavage, HCHO, and this aldehyde, if you oxidize the aldehyde, it will be converted to acid. It will be converted to acid. That is the case. That is the case. Suppose if we have this, very easy. Suppose if you have this, first of all cleave kar do. This is an aldehyde, it will be converted to 1 carbon wala acid. This is a secondary alcohol, it will be formed to ketone, but it is unstable, so it will form to 1 carbon wala because there is only 1 carbon acid. This is a 1 carbon wala alcohol, but it's a primary alcohol, so it will be converted to 1 carbon wala aldehyde. HCHO. Done. And normally this HCOH, it actually breaks down into H2O plus CO2. They can give these kind of things in the options as well. HCOH, it actually breaks down into CO2 plus H2O. Okay, right. Now some important points. 100% ethyl alcohol, 100% ethyl alcohol is known as absolute alcohol. Second, 95%, one second. Wait, let me charge the laptop. One second. Right. So 95% absolute alcohol plus 5% water, it is the spirit. This one is important, really important. 80% petrol plus 20% ethyl alcohol. It is known as power alcohol. Okay, because it is a fuel. This is used as fuel. Right. Now, normally we know that what we drink as alcohol, that is the ethyl alcohol, it actually affects our cerebellum. Okay, that's why the body balance is being affected. Now, 4. Alcohols, see this very carefully. This is a very important, very important point. Alcohols with group, like, suppose if I show you, like, suppose we have alcohol like this, any R group or H. Okay, they gives they actually give haloform test. Haloform test. So haloform can be iodoform, chloroform, bromoform, but most preferably iodoform is the important test. We'll discuss about the haloform test in the next class. And 5th, alcohols also give positive Lucas test. So if there is an ROH, ZnCl2, plus HCl, RCl plus H2O. So this is the Lucas test. So normally the tertiary alcohol better gives Lucas test, then secondary, then primary. So if you have R, C, R dash OH, C, second if you have R, CH2, CHOH, CH3, sorry, R2, RR1, and suppose if we have RCH2OH, so this is the primary, this is the secondary, this one is the secondary actually, secondary, and this is the tertiary. So tertiary one will give better results in the, or better positive Lucas test. These things are really important, right? So now about ether. In case of ether, we write ether as ROR. We write as alkoxy alkane. We write it as what? Alkoxy alkane. Alkoxy वही होगा, which one is the smaller carbon वाला. Alkane वाला जो होगा, that will be the bigger carbon वाला. Suppose CH3CH2 OCH3. So smaller one is methyl. It will be methoxy. Bigger one will be alkane. So it will be methoxyethane. C2H5O C3H7. Smaller one is ethane. Ethoxy. This one is big, propane. This is the nomenclature, right? So now some important points, informations. Ethers are explosive in nature. Due to peroxy formation. I'll show you. So there is a peroxy linkage. Okay, so you can see that this ROR, so this is a peroxy linkage. So this, due to this linkage, these are very much explosive. Now ethers are also used as solvents. They are used as solvents. Okay, ethers can be also in thioether. So just they won't ask any question like RSR is nothing but a thioether. They won't ask any question from a thioether. Last point of today, okay, that is a cyclic ether. This is a cyclic ether. This is also known as epoxy alkane. This is also known as epoxy alkane. Okay, like CH3, CH2. So this is nothing but this is the epoxy group, and how many carbons are there? 3. So epoxy propane. Okay, suppose there is a CH3, CH2, CH2, CH3 epoxy group. So how many carbons are there? 4. So this will be, and which of them there will be epoxy group? 2 and 3. 1, 2, 3, 4. It can be also present over here, but it is not present in 1 and 2. It is present between 2 carbon and 3 carbon. So it will be 2, 3 epoxy butane. Okay. So today is all about this. So we have actually completed alkyl halides, alcohol, phenol, ethers, some about carboxylic acids, amines, and amide section. Next class we will do the aldehyde ketone portion, where we will discuss mainly the important reactions like Candizar and aldol, then something about isocyanate, and then we will move on to the different effects. In the meantime, I will give you a lecture on isomerism. Please watch the video lecture, and that will be all. Okay, so please give me your honest review. Are you liking the way I'm taking the chemistry section? Is it helping you guys? Please let me know. If you guys have any problem, I will upgrade myself so that it will be easier for you to understand. So is this way of teaching helping you or not? Please let me know. As you guys have studied chemistry in your +2 level, that's why I'm taking in this way. Is it helping you guys? You can answer that in the chat section. Okay, right. So it's cool. Then we'll call off this meeting today, and we'll meet you in the next week, I guess. But the point here is that I think 26th there will be a, no, 26th, no, it's fine. You will have the classes normally, no problem. I will take you on an extra class, okay, so that I will take this chemistry fast. So in the meantime, I will give you a lecture on the, so that we can practice some reactions. Okay, just wait for 1 week. Okay, just wait for 1 week. I will give you many PDFs. Okay, don't worry, I will give you many PDFs so that you can solve some questions. And please buy this book. Okay, there's a book called NEET in 40 days. Okay, please go through the physical chemistry section. You don't have to remember all the go through all the important questions. No, physical chemistry, you just have to see the theory portion. I will give you this. If you don't have this book, I will give you the thing which I've told, the theory portion of this physical chemistry. I will give you the PDF in the PDF form. I have this book, I can give you that. But for your practice, you can go through this book. This is an easy book. Or just wait for 1 week. I will give you some question answers, because I have some questions in my hand that will be easier for you. Okay, so I'll try to give you some questions, so that will be easier. And please go through the previous year question papers, because any book we have, because there is no particular chemistry book for IIT JAM, you just solve the previous year's questions. That will be enough. 10 years BT. Bus, that will be enough. They won't ask questions too much hard, and we will solve questions over here. Don't worry about it. Okay. So organic हम class में इतना अच्छे से practice कर लेंगे ताकि, and please write it down in your copy, that will help you. That is easy. Okay. So let's meet in the next week. Okay. So in Friday there will be a class on genetics. Rishabh will take the class. Okay. And Sunday will be Sevashi's class. So bye guys.